Welcome to Resilience to Pandemics and Natural Disasters in Chemical Plants. There's been a few models published about resilience over the last few years, including this one by Hollinger and Woods that looks at capacity, flexibility, cohesion and tolerance, and all about how a system can adapt and handle threats. Some other models also show why in hurricanes and floods we have policies and procedures for preparation before the event, for event management during, and for the immediate recovery, and also for restoration after the event. And then clearly at the end of all these we always have investigations or incident investigations to look at, or lessons learned to look at how we improve and learn from what we went through. And this is just the same for pandemics, preparing beforehand next time, right? And many plants have prepared for pandemics, and we'll talk a bit more about how that worked out later. There are some commonalities and there are some differences when you compare our experience with flooding and hurricanes to our experience with COVID-19. In flood and hurricanes, it's often a short-term disaster, and we've already learnt from experience. We know what to prepare, what people need beforehand. We'll get water and ice and gas or petrol in so people can get to the plant when the roads are open. We know that we need to have special spares. We know that housekeeping is incredibly important, and to make sure everything's tied down and secured before a hurricane's coming in. We know we need to shut down and remove chemicals, and often in Houston, for example, you'll see trains leaving Houston with chemicals to get it away from the danger zone. We know we need to protect equipment, particularly sensitive instrumentation. We know we need to check equipment, particularly safety critical equipment, before we start back up. And we have to support people with supplies, to some extent with stress, particularly those who lose houses or cars. And we know we need to do all our readiness to operate checks, particularly safety critical equipment, before we start up. So we sort of know how to handle floods and hurricanes. Pandemics, it's quite different. We're operating over a long term during the pandemic situations. We may have had some time to prepare, but in this case we had little experience. The key thing not so much is protecting the plant, but is protecting the people, and we've had to develop protecting people procedures. Different types of spares are needed. Masks clearly were a big issue, perspex equipment, and also to some extent raw materials, depending on where they were coming from and how short the supply chain was, and what your critical inventory holdings are like. The control rooms have been locked down, and we've had to put in place lots of extra situations to help people, particularly with mental health. And mental health in its fullest form, because I think everybody will recognise they've had some extra stress this year due to COVID-19 and how it's affected you. We also have to put in place policies to check people rather than checking equipment. And also a lot of stress in making sure people can work remotely, and cyber security. So, some things are the same, but some things are very different. People protection has, clearly become a very big issue, with the control rooms being locked down and people having to work at personal distancing. Engineers have been working from home, and in some cases using video goggles, or in other cases drones that have been used, for example, for pipelines for quite a while. We've had to put in place all of these special COVID policies or pandemic policies, whether it's self-isolation, return to work, but also personal behaviour issues. So, for example, if you have to self-isolate because you've been to some sort of big party, or something that isn't necessarily sensible behaviour, and you have to do that multiple times. Well, is it right that the company should pay you to be self-isolating multiple times? So sites have had to handle that challenge. And clearly, if one person in a shift has to self-isolate, everybody in that shift will potentially have to self-isolate. And therefore that takes out one whole shift from a rotation. And that means that relief shifts have had to be put into place. Clearly the lab and maintenance personnel have had to have policies for adapting the way they work, and also how permits are done, or permits should ideally be done in the field anyway, but obviously lots of maintenance personnel would traditionally be going to the control room, and so that whole situation would have to have been sorted out. And obviously that means that there are fewer people on site, fewer people out on the plant, fewer people in the control room, and so it pushes a lot onto your safety culture and the adherence to policies and procedures, particularly operating procedures and especially safety critical operating procedures, but also in terms of support if things are troubling. There are some things that are common to both, and that is, if you look at the graph on the right, you see this is a plant that I used to work at in Houston. 59% of operational personnel had less than 6 years experience, and that was largely because of baby boomers retiring. But that also still gives us an issue with the most experienced staff are likely the ones to have chronic health conditions. Less experienced staff may have not worked through disasters like hurricanes or other things. They may also not have seen many startups, particularly if you're in a 4 or 5 shift system and your plant starts up once a year or once every 7 years in some cases. You may not have seen some of the unusual situations or emergency situations, and that means drills for safety critical situations are hugely important. But also because of in these, whether it's a hurricane, a recovery from a hurricane, or during a pandemic, people are in a lot of stress. You know, during Harvey, 50 people in the plant I worked at either lost their whole house or had huge issues to their house, and also in many cases lost their cars. So, you know, people are working at work and then they're working at home many hours, and then, you know, potentially living in temporary accommodation. And, you know, even in COVID, we've had people that have chosen to live somewhere different because they don't want to infect their family, or, you know, that they have a long journey to work, so they've got a different situation. We have many engineers, for example, who have healthcare workers as family members, and you know, obviously they've been dealing with the huge influx of patients into hospitals during the peak periods, and that puts a lot of stress on people. But also in the past we've had a lot of cost cutting, and that might have reduced staff, reduced inventories and spare equipment, and in a lot of cases our plants are old. You know, a lot of plants were built in the 70s, and so all that puts stress on our systems, on our need for spares, on our staff, and also for our staff having to deal with unusual situations and making sure they have the training for it. So if we look at risk management and learnings and mitigations, critical inventories are important for both types of disasters, but it may be slightly different depending on the location. But what's important is to have a truly diversified supply chain, and that we need to make sure if we have multiple suppliers, for example, that it would be better they're not from the same region. We need to think about our potential for multiple waves and being able to sustain our operations and being able to work in these new pandemic procedures for a long time, and also the impact it has on people for sustaining those for a long time. But also for hurricanes, there's a stress every year in the Gulf Coast where, there's a potential, and particularly this year it seems to have, the stress has been there for multiple events all year, even coming into the Greek letters for storms. With our risk frequency, we have a good idea of the risk frequencies of hurricanes and flooding in the past, but is that changing because of climate change? And certainly in the last few years, it certainly seems like it. And pandemic, some plants will have had a pandemic risk frequency set. And, clearly the last pandemic that hit the US in a serious way was over 100 years ago, or just over 100 years ago. But do we expect that frequency to change? And do we need to look at our procedures and policies and our risk ranking? And do we need to look at our backup of safety critical roles for future? And clearly our key supplies are slightly different between the two types of disasters. But as we come into reviewing our COVID-19 response, do we need to be increasing our key supplies of masks, for example, and the way we separate people? And obviously that gives us slightly different design challenges for pandemics and safe working distances. Should we be changing the design of our control rooms where we have our engineering stations for the DCSs and SISs and the ability to remotely log in, and how that impacts cybersecurity? Whereas for hurricanes, we're looking at the height equipment is, how we protect critical equipment, such for example as emergency generators is more important. One thing that is really important in both situations, but I think particularly focused on in the last year because of the COVID situation and because of the ongoing relentless stress that COVID is causing, is the really important place for critical procedure drilling. The importance of reducing complexity and administrative load, and looking at how much change we bring in a year and on particular groups of personnel, because people can be just overloaded. And we have different groups, different departments in a site, all are trying to achieve their objectives for the year, and unless it's well coordinated, these changes can just be too much, and we need to learn to work together to schedule them in a way that we can support our people, but also really just focus on the really critical activities in times of stress, and provide means and support for team cohesiveness, particularly operators under great stress on the control rooms, but also for teams that are working offline. And I think, companies all over the world have been looking at that as an important thing, and what can we learn from others to improve our situation. And the other thing is, under stress you're likely to forget things, so the clarity of layout and instructions are really important. Our younger generations are much happier watching YouTube videos, or and we can learn a lot from them. A picture's worth 1,000 words, so why do our procedures have millions of words in them? So we, changing the layout of our procedures, our instructions, but also the layout and design of our equipment in the field. Do we actually design it in a way that is clear and is not going to cause confusion or mistakes? Safety culture is hugely important, and we know that there's a lot less presence in the control rooms in the field, but also people are tired. They're covering maybe lots of overtime because they're covering self-isolating colleagues. Maybe they have stress and family issues. So it's really important that we continue during this pandemic, but after, to improve our safety culture, and that people live safety as a value rather than as a compliance or a mandatory and developing our safety cultures to get to that point that it doesn't rely on presence in the control room to make sure people are following procedures. And clearly we're in an economic downturn, and usually plants have their budgets cut and their capital budgets cut. So we need to be careful that we learn from this pandemic and learn from other disasters that we faced, that we don't cut down to no relief operator capacity. We don't reduce to there's only one person that's trained for a safety critical role or a safety critical scenario. We need to make sure we don't reduce training on these safety critical items, and in fact drills for them are probably even more important when we face stressful situations. The other issue is that, particularly with maintenance and capital expenditure, is in a recession it's normal that companies would cut those, and we need to make sure that engineers and managers have a good way of risk ranking critical infrastructure and critical maintenance, so that we don't cut things that are in a potentially going to get in a bad condition. And assets deteriorate and assets need management, and so a critical asset policy is really important, but also a way that if a capital project, for example, to repair a piece of equipment or to install a safety system doesn't get deferred if it's in a red risk or getting towards a red risk type of scenario, and having systems and policies in place so that engineers can communicate with senior managers in a way that is understood, so we don't have the Challenger type disaster scenario where the engineers know that something's in a bad way and needs, or is going to get towards a bad way and needs some work done on it, and yet cannot communicate to senior managers in a way that they can take on board. So these risk management systems for safety critical equipment is really important. So for resilience for pandemics, we need to learn from hurricanes and floods, but we also need to look at our people policies and protection policies. We need to look at design changes when we retrofit plants and build new plants for personnel protection, and design for impacts of stress and fatigue. We need to look at our critical inventories, PPE and critical staffing. We need to get better at on plant the way we design and the way we handle change, for example, and supporting people so that we reduce impacts like mental health. And we need to destigmatise the mental health such that people can have open conversations about change and work overload in a way that can lead to improvements. We need to continue to work in our safety cultures and values such that it's a belief and lived every day, with procedures that work, with a system that works for feedback of those procedures, and that we get to the point that people follow the procedures no matter if there's supervision around or not. And in the in an economic downturn, we need to make sure we don't cut out our resilience capacity. And thinking about it as resilience capacity is a good way of making sure that we can put some models and metrics and risk management around it. So thank you. This is an introduction to the way we're thinking about risk management for natural disasters and pandemics. And I thank the group at University of Sheffield and my process safety group, my colleagues at Syngenta and Paroxychem. Thank you.